Hi everyone, welcome to week 6 doubt session. I'm waiting for people to join. Um, Hi Tariq, how are you? Great, great. Till what, are you able to do assignments easily or is it difficult for you to do? Great, great. So I hope you would have completed till week 5. Great. So today I will be discussing week 5 assignment for this year and last year week 6 we will discuss the and if time permits then we will move to some other stuff whatever I generally teach here. So let's wait for 5 more minutes. Let some more people join. Hi Jaya, how are you? Jaya, am I audible? Great. Let's wait till 6:10. Good evening. Let's wait till 6:10. Let some other more people join. So, apart from weekly assignments, do you want me to discuss anything else? So, you want me to teach you anything? Whatever you like. If you have anything in mind which you want to study, hi Prashant. Let's let's wait for 2 more minutes and we'll start. So yeah, let's start. The attendance is very low today. Anyways, till now, till last class, I think we discussed week 5 assignment. So week 6 deadline is still far away. So I will discuss week 5. No, we didn't discuss week 5. We discussed till week 4. So week 5 deadline is over. So I'll discuss week 5 assignment first of this year, then week 6 assignment of last year. Okay? Am I audible, guys? Great. So let me let me connect my iPad and or I think by next week or so the solutions will also be uploaded for assignments till week 5. So till then let's discuss so that we are up to date. So what you can do is you can open week 5 this year's assignment on your screen. Okay? And I will be opening sheet where I will be solving it. Is the screen visible? Okay, so this is this week's week 5 assignment. So this week's assignment discussed encoding, one-hot encoding, cross entropy, etc. Neural language models, prediction units, logits, a lot of stuff. Okay, so First of all, did any one of you have any doubts in week 5? Then I'll discuss question by question. If you have any specific doubts, I can discuss it first. Any doubts in week 5? Please guys be interactive, like there's nothing wrong in that. Yeah, you have to find this A11, right? Okay. So what happens is, let me draw it here. So the hello. This is a cap. Ignore that cap. It's just 8, 2, 1. I'll explain the diagram, then I'll go forward. This is 8, 2, 1. It gives output y hat, and there is another bias term, which is 1. So the dotted circles are bias terms that we discussed. Bias is needed to basically create an intercept. So what you do is you connect bias to all the weights, okay, and you connect this x to all the weights. You don't connect x to so x to this bias. You don't do it because it's a bias term. It should be constant. Then you connect this here, this here, this here. Okay. So since you are connecting this this to this, you need to have some sort of matrix to go from here to here, transformation matrix. So that matrix is basically weights. From somebody's mic noise is coming. So you need to have some weights, and I'll discuss that. So so this is say this is say you label this as 1, this so you label this as 0, this as 1, you label this as 0, this as 1, this as 2, okay, and you label this as 1. So biases are labeled as 0, the rest of the weights are labeled as 1, 2, 3, 4. Since it's a 2 layer, so this is layer 1, this is layer 2, okay. So this thing on top in power in bracket 1 and 2, this is representing layer number, and the bottom one, the suffix 1, subscript 1, that is representing what you say, the not unit number, okay. This is representing unit, while this is representing your layer, okay. So now the thing is, how do you compute it? If you have any doubts, let me show you. So you write A11 is equals to, so yeah, also see here, the weight will be written as, for layer 1 it will be W1, and it will be from 0 to 1, so it will be 0, 1. For layer 1 it will be W1, it will be 0 to 2, okay. For layer 1 it will be W1, it will be 1 to 1, for layer 1 it will be W1, 1 to 2. So see how many weights are coming to A11, 1 and 2, these two are coming, so it will be written as W1 O1 times 1 plus W1 11 times X, okay. And it's also written assume sigmoid nonlinearities. So what we do is we apply sigmoid function over this, okay. So ultimately you get is this. So A1 can be found using this. So what is the value of W011? It is 1.0. W111 is 0.7. X is 0.5. So this becomes 1.0 plus 0.35. This is 1.35. Okay. You apply sigmoid over it, so it becomes 1 upon 1 plus e to the power minus 1.35. Can someone solve me and tell me the answer? If the answer is given, yeah, so it should be. Can you just solve it and verify it? Like, I'm not sure you have done it correctly. Or let me solve it. So e to the power minus 1.35 is 0.2592. Okay. So it will be 1 divided by 1.2592 is 0.79415509. Yeah, that's correct. So so the answer is correct, 0.7941. So Jaya, did you get it? Got it? Similarly, you can solve it for A12. So A12 will be again A12 will be summation of these two weights. It will be 02 time 102 weight into 112 into x. This will be summed and it will be computed like that. So to compute y hat, you have to apply sigmoid over A. Not like that. Just a second. So I think the sigmoid should be applied. Since no weight is added here, so your y hat is simply A12. Okay. Just a second. I'm getting a call. Just a second. Sorry. So once you compute it, so how do you compute this? So what you do is you write A12 is equals to sigmoid of something. So what is sigmoid of something? That is your 1 into W201 plus A11 into W211 plus Am I audible? Okay. Sorry. And ultimately that will be A1 2 into W2 what 21. Okay, if you solve it, you will get something that will be the answer. So it will be 1 upon 1 plus sigmoid of this 1 plus e to the power minus times this whole thing, which is written here. Okay. So that will be your y hat. So now assume your ground truth is y equal to 0. Your ground truth is y equal to 0. Okay. BCE loss for x is equals to 0.5. Okay. x is equal to 0.5 or y is okay. Sorry. So x is equal to 0.5 is given to you. For x is equal to 0.5, your y hat is equals to 0.9051. Okay, so since the ground truth is 0, it should be, this number should have been closer to 0, but it is closer to 1. This means the loss will be very higher. So let me write the loss. Loss will be y times log of y hat plus 1 minus y times log of 1 minus y hat. It's something like that, right? The formula was written somewhere here. Y times log of plus 1 minus y times. So this is probability basically. So your y ground truth is 0 times log of something is 0. This becomes 1 minus 0.9051 times log of, sorry, this becomes 1 minus 0 times log of 1 minus 0.9051. So this becomes simply log of 0.0949, something like that. 1 minus 0.9051. 9051, yeah. So if you solve this thing, so let me solve it. Log, I'm just taking log. Let's, if it's ln, you can take ln. I'll also do it for ln, 0.0949. I should not take log, I should take ln equals to 2, and so on the, sorry, it should be also negative as well. Okay, so this is not plus, this is in minus, this whole thing is in minus, so this whole thing becomes 2.3549. This is the answer. I know my computer screen is not shared, so once I upload recording, you can see my calculations which I do in the recording. So yeah, this is the solution from question 7 to question 10. Any doubts on the in the above questions from 1 to 6? Yes. A2, yeah, A21. A12 is this term, A21 is this term. Yeah. J is, yeah, this loss, this is loss, this is J for that unit here. Yeah, so once you compute loss here, yes, once you compute the loss here, so what technically computer does is, it doesn't compute the loss in that way. It just sees in what point of the loss function it is present. Then at that point, so what you do is, you write dou J by dou W at x, at say loss is equals to, or J at J is equals to 2.3549. What is the derivative at this point on loss function? Got it? So yeah. So you would say your loss is like this. So at every point the slope is different, right? So we have to compute the slope, the numerical value of slope, because the equation of slope will be same, but the numerical value will be different. So to compute the numerical value, you have to pass this. At J is equals to this. What is the value of loss? What is the derivative of loss or slope of loss? Okay, so consider this as like this. So at this position, your J is equals to 0.57. So at J is equals to 0.57, the J, dou J by dou W, say I compute for W1, 1 is equals to 0. So for this weight, so the losses, this loss functions, the more weights you include, the more complicated it becomes. So if you take, say, y is equals to mx plus c, so it is a basically slope versus, it becomes a 3D loss. So it becomes a, say, a type of concave parabola, 3D parabola, where you have to compute W0 on one axis and W1 on one axis to get to the minima. So the more parameters, the more weights you include, the loss becomes more complicated in much higher dimensional space. So that increases the complexity. So that's why we compute it with respect to each weight and we try to optimize it. And that is why we have the problem of this local minima and global minima. So once you have many, so that's why we prefer like that's why we say na कि that's why we need many other optimizers apart from gradient descent. We have Adam W, etc., etc. Because those optimizers are great at converging to global minima compared to these basic gradient descent. And there are some other weight initialization techniques which try to remove much like a lot of local minima from that loss function, so that there are less local minimas and global minima which is much lower compared to local minimas. Okay, so that is the problem with deep learning, and this is how we try to get rid of it. Got it? At each layer it's constant. Why is it added? I explained in one of the earlier lectures. So consider you have a equation y is equal to x square, or say y is equal to x. Okay. So I give you a straight line. I have give you a set of points. Let me show you here. I give you this set of points, and you are asked. Hi Praveen, good evening. You are asked to fit a line. So if I ask you y is equal to mx, you have to compute m. So whatever m you compute, this line will go like this, will go like this, will go like this. It will not go like this because you don't have some constant weight here. This is the bias term which you add to basically shift the axes. Okay. Even if you take y is equals to x square and your data points are given like this, something like this, but your parabola will always fit it like this. Like something like this. Say the parabola will fit something like this. It won't shift the axis here or here or here. That's why you add this constant term for axis shifting. Okay. Sorry. Generally, the bias term is put as 1 because we don't want to multiply our previous values to that term. So bias is technically this 1 is bias term, but we are computing some weight here. We are computing W201. This is the weight. This is the C value. Y is equals to mx plus C, which we want to compute to basically shift the axis per layer, per each layer. We want to shift this axis, because while summing this, we will multiply this with some weight, this with some weight, but we will leave out the bias term. We will leave out the shifting term. Okay, so that's why we add bias. Okay. So, any other doubts from question 1 to question 6 in week 5? Some new people have joined. Hi everyone, good evening. Yes. No. I haven't discussed question number 6 yet. See, this is like if you find the solution, then the solutions will be uploaded. They would have written the code to compute this. So I can solve it, but it will ultimately take so much time to solve it. Like I'll have to compute loss with respect to each weight. Okay. Yeah, I will explain the steps. Numerically I won't be able to compute it. my code was just for basic reference. I don't think that code was perfectly written. Okay, then I'll solve it and I'll check it later. Well, I can solve, like, let's see. So to solve question number 6, I will have to use this table. For question 5 and 6, consider logistic regression with sigmoid loss. Learning rate alpha is equal to 0.1, initial weight something. So I have feature 1, I have feature 2, I have true label. So feature 1 is x1, feature 2 is x2, true label is y. This is 1, 3, 5, 7, 9. This is 2, 4, 6, 8, 10. This is 1, 0, 1, 1, 0. Okay, so when x1 is equal to 1, x2 is equal to 2, the output is 1. So whatever it is like that. So what I'll do is explain it very simply. So what we do is, we have a logistic regression model. So it takes two inputs, x1, x2. This is a1, 1, which takes us to y hat. We can add a bias term. Okay, since it is given 3 weights, initial weights are 3, so we need to add bias term because this weight is 0, then this weight is 0, this weight is 0 initially. So we need to add bias term. It is imperative from there. So what you do is you compute a1 1 is equals to 0 into 1 plus 0 into x1 plus 0 into x2 for all, let me add it I here, for all I belonging to 1, 2, 3, 4, 5. Okay, so there are 5 rows, 1, 2, 3, 4, 5. So for all I belonging to 1 to 5 we compute it. Let me add one more superscript here, I. Okay. So it is computed like that for each thing, and ultimately what you do is you compute the loss. So when you compute the loss, this thing becomes y hat I. So loss is summation from I is equal to 1 to 5 yi minus, comma y hat I. Okay, total loss, no, because it should not be minus, because the loss will be logistic. This will be L, this is LT. LT means total loss for I is equal to 1 to 5. So we computed like this, where L yi, comma y hat I is BCE loss, which is minus times y ln of y hat, let me add I here, minus times 1 minus yi ln of 1 minus y hat I. Okay, so you compute for 1 unit, is the screen visible? Okay. So you compute it for all units, all 5 data points, and then you sum it. That's how you get the total loss. So the question 5 gets solved using this. Okay. So like first epoch, I can seriously solve it manually. So for all initial points, the loss will be 0. Okay, like for all initial weights, so for I is equals to 1, loss will be 0. For I is equals to 2, loss will be 0. Is it 0? Let me check. Just a second. No, loss will not be 0. This A hat will be 0, sorry. This Y hat will be 0. Y hat I cap will be 0. Y hat I cap will be 0. Okay. So once you compute BC loss, you will find that since it is 0 most of the time, so for these two labels the loss will be 0 because the labels are accurate. For these three labels, loss will be different. So what is ln of 3? Can you somebody compute it? ln of 3. ln of, sorry, it will be ln of 2 or 3. Let me check that. So for y I is equal to 1 will be minus times 1 into ln of 1 minus times 1 into ln of 1 minus times 1 into ln of 1 for this whole thing. 1 minus 1 will be 0, 1 minus 1 will be 0, 1 minus 1 will be 0. This will be 0 initially, and this 1 minus 0 will be this will be 1 minus 0. Okay, for 0 label it will be 0. This will be 1 into ln of 1 minus 0. Let me check. It should be 0 error. For I is equals to 1, let me compute the loss. For I is equals to 1, y hat I is equals to 0, right? Since all weights are 0. So this L becomes what is 1 into ln of 0. Okay, minus times 1 minus what is y2 label 1 ln of 1 minus blah blah blah. Okay, so since this is 2 label, first of all this thing becomes 0. So it will be ln of 0. What is ln of 0? ln of 0 should be infinity, but yeah, it is. The probability is not 0. Oh, sorry. I forgot to apply sigmoid function. Sorry. My bad. Sigmoid will be 1 by 1 plus e to the power 0. That will be 1 by 1 plus 1. That will be 0.5. So this becomes 0.5. Okay. So ln of 0.5 is equals to ln of 1 by 2, which is ln of 1 minus ln of 2. Am I right? Hello? Okay, so it will be minus 0.693. Minus sign will be already there. So it will become plus of 6.0693, something like that. Okay. So yeah, that is the answer. And this will become minus, this will become plus, then this will become minus ln of 1 plus ln 2 minus ln 1 plus ln 2. So we have minus cancel, and this thing becomes ln of 4 minus ln of 1, ln of 3, something like that. If you try to solve it, you will get it. We have just three labels like that. What is the answer? I think it should be 0.693 only. Did anyone try? But I mean, question number 5. Did you get it correct or not? Okay. Okay. Anyways. see, the loss will be something like this only. I mean, I'm not able to compute it because I'm doing some mistake here, but the basic is computed like this only. So for each point you have to compute it, you have to sum it. Okay. So what you do is now, so if you see this thing, this whole thing, this loss function. Okay, what is the derivative of this loss function? Dou L by dou W. So since your y hat I is equals to your weight, dou A1 1. Where's that C? Okay. So if you compute it, I don't know what is the derivative of BCE loss with respect to this weight. So I think it should be this is constant. This becomes constant. Sorry. This becomes constant. So it becomes something like this minus times yi. I'm doing it for 1 unit only into 1 upon y cap I minus times 1 minus y I times 1 upon 1 minus y cap I, and since it is negative, so this becomes plus because that negative sign, again the derivative of that unit becomes in minus 1, so this becomes plus. So it should be, sorry, it should be something like this only. Am I right? Mathematics experts, people. Praveen, am I right? I can. Okay. What? Week 5 CS49. Yes, I have the code with me. In that code, I haven't computed the derivative. You might have used linear regression code, I think. That was week 4 or week 3, something like that. So, like, even if you cannot compute it, you can, let me just, what is the derivative of BCE loss? Just a second. Let me ask ChatGPT what is the derivative of BCE loss. This becomes 4 minus 8, 4 plus 8, 12, minus 7, minus 1. So it's again 0, and this is again 9 for 14 and 14 0. So the answer will be 0, 0. Sorry, 0, 0, 0, 0. That's what's given. See. 1 into 1, 2 into minus 1, 4 into minus 1, 5 into 1 is become 0. So that's how you do it. That's how you perform convolution operation on by striding over that array. Question number 5. For resulting output matrix from question 3, a 2 by 2 max pooling operation is applied. What is the final output matrix after applying 2 by 2 max pooling? So applying, yeah. That's that is what we do now. That is what we do. We learn the kernel instead of weights in CNNs. We have kernels. Okay. So initially these values have been given. So what you do is you compute loss and then you back propagate on these kernels and you learn the values of these kernels, so that you get some features in these matrices instead of 0, 0, 0, 0. Okay. So what you have. Yeah, this is just an example. You have some x, you have some weight, you have some A. So that A is 0, 0, 0, 0, your X is that matrix, and your that W is that kernel. So you learn that kernel by backpropagation. Okay. So yeah, on this thing, a max pooling of 2 cross 2 is applied. So max pooling means whatever maximum value is in this 2 cross 2 matrix on resulting output matrix. So this is the output matrix. On this 2 cross 2 matrix, what is the maximum value? It is 0, so answer is 0. So even if you see here, while applying a 2 cross 2 max pooling operation, we look for maximum value in each 2 cross 2 subregion of matrix. In this case, since the matrix is 2 cross 2 region with all elements 0, the maximum value selected will be 0, so answer is 0. Okay. For resulting output matrix here, we have solved it. What are the distinctive features of inception network? Just a second. Yeah. So inception network you see is you have let me show you inception network. Inception network. So this is an inception network. Okay. So as you can see, there is a nice tutorial of about inception network. I think this is the one. This is a YouTube video. So as you can see, what we do is we apply multiple convolutions. So why have you studied? Has anyone of you studied week 6? Nobody. Okay, so let me tell you what an inception network is. So you take output, you apply kernel, you get some output. The problem with this thing is, for big images, also for big number of parameters, you apply multiple kernels and multiple things. Number of parameters become very large, like in the scale of 60 million or something. So inception network, what it does, so instead of applying say, where did it go? Instead of applying say 5 cross 5 kernel, so you see, if you apply 5 cross 5 kernel and you do multiple operations, so you get parameters in the range of 60 million or something. So what inception network does is, inception network breaks down the operation in multiple kernels of different sizes, and then it sums it. So instead of, it's sort of say increasing surface area of convolution, increasing the feature capture power, but reducing the size of kernel. And once it does this operation, it reduces the parameters from say 60 million or to 12 million something. So it reduces it 5 times. So this is what inception network does. If you study week 6, you will be able to find out. It's very basic thing. Okay. The same convolution layer has multiple filter sizes. That is the correct answer. Consider a CNN output. Let's discuss question number 7. Okay, question number 7. Any doubts till now? Any doubts till now? Are you audible? Okay. So we have a CNN with input volume 64, 64, 20. We need to apply a layer of 16 filters with size 3, 3, including a bias term for each filter. How many parameters does this layer contain? Again, same formula. So filter size is 3, 3, depth is 20, 20 plus 1 into number of filters is 16, so we get 2896 parameters. correct? Okay. Am I audible? Am I audible, guys? Okay, okay. So question number 7 is very easy. Now this is a very good question. This is an interesting question. You will study. Like I love CNNs just for this reason. They are very intuitive compared to other networks and the stuff. CNNs are very intuitive, and that is the reason they were created. Like it was very intuitive how to capture image, how to capture image data. So that's why they were created, and that's why the research around it is quite interesting. So 0 points have been avoided because this question solution might have some issue, but let's discuss the solution. Let's discuss here only. You have an input feature map size 7,7 aim to increase spatial resolution to 14,14 through a transpose convolution operation. You decide to use filter size 2,2. What is the sprite padding values you should use in transpose to achieve size of 14,14? So your answer is 14 minus 7 plus 1 will be the given answer. Okay, so it is something like this. Okay, so what is the sprite? The sprite is okay. Try. They have given try all options by yourself. So you will find that for sprite 2 is equal to 2 into 7 is your feature map size 7 minus 1 plus k is your kernel size 2 cross 2 minus times 2 times into padding is 0. So they are saying use padding 0 sprite 2 to get kernel size this. Okay, so you can just mug up this formula. This is like these are standard formulas. These two formulas are very standard formulas. You can mug them up, and they are very good at solving questions. Like say this is again used here. Okay, so I don't think so it's any use of discussing these questions again and again. So applying convolution kernel, what will be the output matrix? Okay, follow-up question, applying transpose convolution operation. So you can, like, very simple. I've discussed that, written the solution here. You can just go through the solution, like it's very basic. Okay, we will not have time to discuss, otherwise we will not be able to discuss the coding part. Okay, so any doubts in week 6? Like it's very basic, basic questions, basic solution. Any doubts? Yeah. Which question are you talking about? Okay. Features is okay, okay. So see, feature is in image. Feature is number of channels. Okay. So your RGB image has 3 features. Okay. Each one RGB image has 3 features. RGB channels. Okay. So that is used in those terms only. Yes, you have to match that. Otherwise, it will show error. It will show shape error. If you say define the whole neural network, whole CNN network for say 12 features, and you give it a 14 feature image, it will give error. Yes, everywhere it's the same case. Yes, everywhere. Yes. everywhere it should be matching. If it's not, it will give error. For some images, if the channels are not there, what you do is, hello, you add a zero channel. Yes, yes, I can hear you. Hello, am I audible, guys? Guys, am I audible? Okay. So yeah, for everything, the features should match. Okay, if you define a network to manage to compute for 14 features, you should give 14 features. Otherwise, it will give error. Okay. So it will also give me similar something like that. Yeah, so binary cross entropy loss is minus times log of p by minus. So yeah, so it is y into 1 minus 1 upon y hat minus times 1 minus y upon 1 minus y hat. Okay, it's not plus. It's not plus. I don't know. It should be plus. It is plus, right? I think the ChatGPT is doing. Acha. So it has taken minus outside. So it is minus. Yeah, it is plus. It is plus in between. Correct. So I can share my PC screen and you can see it. Just a second. So is this ChatGPT visible? So if you see, it becomes minus times here, minus times y upon p plus times 1 minus y upon 1 minus p. Okay. So just a second. Let me share iPad again. So yeah, this is the basic derivative which we need, because since we have only one weight, one logic based weight in this thing. Actually, we have three weights. Oh yeah, for initially for that 0 0 1 1. Just a second. Yeah, we have three weights. For all three weights, we have to compute it. And yeah, we have three weights. this one, and this one. We have to compute logics with respect to all three weights. Okay. So try solving it. If I'll do the code after some time. I'll do the code for derivative as well. Okay. Let's see other questions. I'll do the code after we discuss assignments. From 7:15 I'll start coding that. Okay. So till then, any other doubts? Question 4 should be simple. 5, 6 we have already almost solved. This 6th question I'll solve it in code. Okay. Question number 1, 2, 3 are very simple, I think. Right? Any doubts in question 1, 2, or 3? Okay, so what? Let's. Yeah. It is log to base and base e. It is always natural log. Okay. Because why do we use e? Because since we are doing 1 upon 1 plus e to the power minus something, right? That's why we use log of base e, which is equals to ln. To compensate for this, we use this type of loss function. Otherwise, the optimization will not be, local minima based. There will be a lot of local minima. There won't be any global minima like that. So that's why we prefer ln over say log 10 or log 2, because we have used something similar to sigmoid function. We have used sigmoid function which contains exponentiation, so we have to negate that exponentiation using this type of loss. Okay. So yeah, we are done with week 5. Current year, let's go to week 6 previous year. Okay, week 6, from week 6, this whole thing becomes quite interesting. So let me share my PC screen. iPad's job is done for now. Okay, screen is visible, right? So this week 6 has CNNs. Week 7 has CNN training, transfer learning. CNN training is quite simple to what we are doing in logistic regression and neural networks. Okay, so let's open week 6 assignment. Week 6 quiz. And these are the solutions. So since you cannot see both of the things, so I will not be able to solve it. I will show you here. So this is week 6 assignment and these are the solutions here. So with an input volume of so you have studied week 6, right? Or shall I wait for next week to solve it? The deadline is still, I think, 5th of March. But anyways, I'll solve it. I'll just show you. Input volume of the image is this. What will be the number of parameters of filter size 2 by 2? Okay, so this is an image 32 cross 32 cross 14. Okay, whatever it is, it's a logit. Am I audible? Hello? My screen is not. Okay, so 32 cross 32 cross 14, so it's basically a cube type of thing. It's a 3D image, or not 3D, yeah, 3D image with 14 channels and 32 width and 32 height. Okay, so number of parameters required. Let's see the solution. Input volume size is this. Number of filters is 10. Size of 2. Bias term for each filter is added. Okay, so total number of parameters will be filter height into filter width into input depth plus 1 times number of filters. So filter height is 2, filter width is 2, input depth is 14. These are number of channels plus 1 into number of filters is 10. So you get 570 parameters. Remember this formula will come handy when you are solving it. So either you can screenshot my screen right now, or I will share this anyways. Then say na it's not shared. Sorry. Now is it visible? Hello? Okay, good. So are you able to see this formula? Filter height into filter width into input depth plus 1 times number of filters. Study week 6, you will find this formula there if you haven't studied it yet, and then try solving this question. Okay, I'll share the question. Let me upload it right now, in fact. So week 6 solution is uploaded, last year's. Okay, so next question is, which feature distinguishes CNN from fully connected networks? Sorry. Which feature? Yeah. No. It's nothing like that. I don't get. Filter is kernel. Whatever you multiply now, the convolution kernel, that is this filter. This is I thought you're saying feature. Okay, so you have 10 convolution kernels of size 2 cross 2. Okay, which you apply. So that's how it's done. So anyways, try studying it and then try solving it. You will be able to do it. Oh, question to solution is not given, right? It should be given here. Let's see. CNNs require large computational resource pools directly correlating with improved performance. No, they don't require. Fully connected networks, if they start computing images, they will require that much information, that will computation resource. Design of fully connected network optimizes for sequence data processing inadvertently increasing the factor. No. FCNs are not good for image processing, and although they are good for processing sequential data, and in fact not sequential data, they are the RNNs and LSTMs have been invented to process sequential image data, sequential data. Streamlined processing flow of CNN characterized by monetary source. No, not at all. CNNs leverage localized filtering, shared weights to effectively capture and interpret special relationships within images. Yes. So yeah, this is the correct answer. Okay. So let's go to next question. Common data for next three questions. Question 3, 4, 5. What is so you have input matrix A, you have a convolution kernel K. What will be the shape of output matrix after applying convolution kernel? So see, 1, 2, 3, 4, 5, 6, 7, 8, 9, and this is 3 cross 3. This is 2 cross 2. So the answer, the shape is 3 minus 2 plus 1. The formula should be something like that. Yeah, this is 3. 3 means input matrix A. This is A. It should be A minus K plus 1. So n is the size of input matrix, K is the size of kernel, plus 1 is added because since we are overlapping some of the points, that's why. So this becomes n minus K plus 1. So that is 2 cross 2. This much has been written, no problems. Yeah. So what will be the output matrix after applying convolution? So initially, let's see for these 4 values, 1, 2, 4, 5. On 1, 2, 4, 5 you apply this convolution. So whatever you get is 1 plus 1 minus 2 minus 4 plus 5. So this becomes 6 minus 6 becomes 0. Then you apply convolution on this matrix. It becomes 2 minus 3 minus 5 plus 6. So that will become 8 minus 8, 0. Then you apply convolution here. This becomes 4 minus 8, 4 plus 8, 12 minus 7 minus 1. So it's again 0, and this is again 9 for 14 and 14, 0. So the answer will be 0, 0. Sorry, 0, 0, 0, 0. That's what's given. See. 1 into 1, 2 into minus 1, 4 into minus 1, 5 into 1 is become 0. So that's how you do it. That's how you perform convolution operation on by striding over that array. Question number 5. For resulting output matrix from question 3, a 2 by 2 max pooling operation is applied. What is the final output matrix after applying 2 by 2 max pooling? So applying, yeah. That's yeah, that is what we do. Now that is what we do. We learn the kernel instead of weights in CNNs. We have kernels. Okay. So initially these values have been given. So what you do is you compute loss and then you back propagate on these kernels and you learn the values of these kernels, so that you get some features in these matrices instead of 0 0 0 0. Okay. So what you have, yeah, this is just an example. You have some x, you have some weight, you have some a. So that a is 0 0 0 0, your x is that matrix, and your that w is that kernel. So you learn that kernel by backpropagation. Okay. So yeah, on this thing, a max pooling of 2 cross 2 is applied. So max pooling means whatever maximum value is in this 2 cross 2 matrix on resulting output matrix. So this is the output matrix. On this 2 cross 2 matrix, what is the maximum value? It is 0, so answer is 0. So even if you see here, while applying a 2 cross 2 max pooling operation, we look for maximum value in each 2 cross 2 subregion of matrix. In this case, since the matrix is 2 cross 2 region with all elements 0, the maximum value selected will be 0, so answer is 0. Okay. For resulting output matrix here, we have solved it. What are the distinctive features of inception network? Just a second. Yeah. So inception network, you see is you have let me show you inception network. Inception network. So this is an inception network. Okay. So as you can see, there is a nice tutorial about inception network. I think this is the one. This is a YouTube video. So as you can see, what we do is we apply multiple convolutions. So why have you studied? Has anyone of you studied week 6? Nobody. Okay, so let me tell you what an inception network is. So you take output, you apply kernel, you get some output. The problem with this thing is, for big images, also for big number of parameters, you apply multiple kernels and multiple things. Number of parameters become very large, like in the scale of 60 million or something. So inception network, what it does, so instead of applying, say, where did it go? Instead of applying, say, 5 cross 5 kernel, so you see, if you apply 5 cross 5 kernel and you do multiple operations, so you get parameters in the range of 60 million or something. So what inception network does is, inception network breaks down the operation in multiple kernels of different sizes, and then it sums it. So instead of, it's sort of, say, increasing surface area of convolution and increasing the feature capture power, but reducing the size of kernel. And once it does this operation, it reduces the parameters from, say, 60 million or to 12 million something. So it reduces it 5 times. So this is what inception network does. If you study week 6, you will be able to find out. It's very basic thing. Okay. The same convolution layer has multiple filter sizes. That is the correct answer. Consider a CNN output. Let's discuss question number 7. Okay, question number 7. Any doubts till now? Any doubts till now? Am I audible? Okay. So we have a CNN with input volume 64, 64, 20. We need to apply a layer of 16 filters with size 3, 3, including a bias term for each filter. How many parameters does this layer contain? Again, same formula. So filter size is 3, 3, 3, 3, depth is 20, 20 plus 1 into number of filters is 16, so we get 2896 parameters. Correct? Okay. Am I audible? Am I audible, guys? Okay, okay. So question number 7 is very easy. Now this is a very good question. This is an interesting question. You will study. Like, I love CNNs just for this reason. They are very intuitive compared to other networks and the stuff. CNNs are very intuitive, and that is the reason they were created. Like, it was very intuitive how to capture image data. So that's why they were created, and that's why the research around it is quite interesting. So 0 points have been avoided because this question solution might have some issue, but let's discuss the solution. Let's discuss here only. You have an input feature map size 7, 7, aim to increase spatial resolution to 14, 14 through a transpose convolution operation. You decide to use filter size 2, 2. What is the sprite padding values you should use in transpose to achieve size of 14, 14? So your answer is 14 minus 7 plus 1 will be the given answer. Okay, so it is something like this. Okay, so what is the sprite? The sprite is okay. They have given try your options by yourself. So you will find that for sprite 2 is equal to 2 into 7 is your feature map size 7 minus 1 plus k is your kernel size 2 cross 2 minus times 2 times into padding is 0. So they are saying use padding 0 sprite 2 to get kernel size this. Okay, so you can just mug up this formula. This is like, these are standard formulas. These two formulas are very standard formulas. You can mug them up, and they are very good at solving questions. Like, say this is again used here. Okay, so I don't think so it's any use of discussing these questions again and again. So applying convolution kernel, what will be the output matrix? Okay, for the above question, applying transpose convolution operation. So you can, like, very simple. I've discussed the written solution here. You can just go through the solution. Like, it's very basic. Okay, we will not have time to discuss. Otherwise, we will not be able to discuss the coding part. Okay, so any doubts in week 6? Like, it's very basic, basic questions, basic solution. Any doubts? Yeah. Which question are you talking about? Okay. Features is okay, okay. So see, feature is in image. Feature is number of channels. Okay. So your RGB image has 3 features. Okay, each one RGB image has 3 features, RGB channels. Okay, so that is used in those terms only. Yes, yes, you have to match that. Otherwise, it will show error. It will show shape error. If you say define the whole neural network, whole CNN network for say 12 features, and you give it a 14 feature image, it will give error. Yes, everywhere it's the same case. Yes, everywhere. Yes, everywhere it should be matching. If it's not, it will give error. For some images, if the channels are not there, what you do is, hello, you add a zero channel. Yes, yes, I can hear you. Hello, am I audible, guys? Guys, am I audible? Okay. So yeah, for everything, the features should match. Okay, if you define a network to manage to compute for 14 features, you should give 14 features. Otherwise, it will give error. Okay. Mm-hmm. Yeah. Yeah, so 0,0,0 value for RGB gives you white image, while 255, 255, 255 gives you black image. You can see let me show you. RGB color picker. So if I search it and see, I go to some black color. I go to some. What's happening? It's very slow. So if you whatever you go to the lowest possible color, you will get values closer to 0. So let me add 0, 0, 0. It is giving me perfect black. So these values are defined and within the range. So see, when I defined R is 255, it gives me perfect red color. Okay. If I define 255 green, it gives me yellow color because R plus G is yellow. So if I define 0, 255, 0, it gives me green color. Okay, if I define 255, 0, this thing, it gives me this thing, blue color. Okay, so compute black color, we mix all of this. Sorry, 255. It gives me, perfectly white color if you apply these three values. So your values of RGB always change between 0, 255. So that's how you compute this thing. Okay. So any other doubts in CNN, in logistic regression, linear regression, whatever? Because then we will discuss the coding part. Or I can teach you CNN if you want, like let's say basic stuff. Whatever you like, I can do it. I say something. Mm-hmm. 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 That is a video. Yeah. Yeah. Yes, correct. To manage that temporal data, temporal nature, we need RNNs. Yeah. No. The basic things are simpler. You compute matrix at time t. Okay. Then you travel that matrix over time t plus 1, t plus 2, t plus 3, and you see how is it evolving, and then you learn it that way. Okay. So assume you do it for a picture. You take all the weights, then you apply RNN. You take that whole unit and then apply RNN over it. All operations are computed for different times on pictures only. Okay. It's a sequence of pictures. Yes. Yes, for RNNs, In case of videos, each neuron will act as a each unit will be a CNN unit, and while the computations will be in sequential manner to compute the video thing. So caption generation and video labeling, etc., etc. These all things are done using that only. Okay. Yeah, that will it. No problem, no problem. I cannot share it. You can just ping it here. Like you can tag me and ping me here. This Q&A part. Okay. No, but like still sharing personal number won't be feasible for them. Yeah, it should be. It should match. Like the features part should match. Otherwise, what's the point? Like that won't be consistent. Okay. Data should be fine. Your loss function should be correct. These are techniques you use. Your data should be accurate. Your label should be correct, etc., etc. Okay. Mhm. So that's the problem. That's the problem you might be facing with data. I don't know. Like okay. Yeah. These all are experiments. Like if it works well with normalization, if it doesn't work, so you have to do it. So these all are like experimentation parts. There's no theory behind it. It depends on data to data, case to case. Okay. No. It's not mandatory. It's preferred. It's not mandatory. It's always preferred. Okay. There are functions like in TensorFlow there is a normalization function. Batch normalization is done layer by layer. Then layer normalization is done. Okay. Sorry. No. You don't have to do it. You don't have to do it. The model is computed that way. You don't have to do it. Okay. Yeah. Sorry. In regression cases, you have to take it to original value. In like linear regression case, in classification cases, you don't have to do it. Okay. So, any other doubts? Any other doubts? Hello. Sorry. Okay. So what you guys can do is try understanding this thing, which I uploaded here. Okay. And you can start writing code for logistic regression, since some of you might have faced it, in fact faced an issue. So let me do it for you. So what I'll do is I'll generate the whole code here using Gemini. Okay. So just a second. I'm uploading it here in this. If you go to this sheet which is shared to you, okay, and this drive link is there, so I'll upload the code. Say 245 code is being uploaded. Okay, just a second. Give me. I need a 2-minute break. Okay. Hello? Hello? Am I audible? Okay, so let me generate. So write logistic regression code on this data with back propagation. Update. Let's see if it's able to do it. Yeah, so see, it's doing the same thing. For weight 0, error into the gradient is the error part into prediction into 1 minus prediction. Okay. So it's sort of similar to prediction is y upon 1 minus y, something like that. So ultimately that's how you do it here, and you will get to it. So let me just run the code. Okay. So as you can see, for label 0 the values is close to 0, for label 1 the value is close to 1, for label 0 the value is close to 0. This means these gradients are working. Okay, so you should try computing it like this. I will update this file and try running it, and you might be able to, if you face some error, let's discuss it next week. So that's how the basic back propagation is done. Okay, so try doing it. This is like the very basic step for computing backprop. This is CS49. Opening this, Google Drive, upload this. Okay, so try using this code and see if the output comes or not. So yeah, I think let's wind it up for today. I'm tired, and let's meet next week and discuss what should we discuss next week. We will discuss assignments, and we will discuss coding for CNNs. Okay, we will code CNNs. We will take some basic image, and we will load that image, and we will compute kernelization, striding, padding, and what you say, the max pooling, etc. These all operations, and I'll show you the basic operation, how the concept like on a small data. Yeah. On a small small image, I'll show you how inception network reduces the number of parameters. Okay, so these all things I'll show you. So yeah, let's speak next week. Next week will be March 6, I think. Yeah, it will be March 6. So let's meet on March 6. Until then, thanks a lot, guys. Bye bye. Take care. Any doubts you have till now? Or any more thing you want to discuss? So yeah, I think that's all. That will be all. Let's end this session and let's meet next week. Thanks a lot, guys. Bye bye. Take care. Good night.